So hello everyone. Today we'll start with chapter 20, electromagnetic induction. So before we start, we have to revise something from the first semester. In chapter 16, we said that we have Ohm's law. Ohm's law, it was I equal to V divided by R. So again, to have a current, which is I, we need power source. Even the power source is DC like a battery, or even it's AC like electricity. So since we have a voltage here, which is V, that means we have a flow of charge. The flow of charge will produce I, current. So to have current, we need power source, even DC or AC, and we need R, resistance. Today, in chapter 20, we will produce an electricity from the magnetic field. In chapter 19, we said that we have electromagnetic field and we have magnetic flux. Magnetic field, it was B, and magnetic flux, it was phi. So electromagnetic induction is the process of creating a current in a circuit by changing magnetic field. So for example, now we have a generator. We have magnet poles here. We have north and south. So here in this area, we have a magnetic field area. Since we have here a loop, solenoid, we have a circuit here. When the circuit will start rotate, that means we have a changing in the magnetic flux. The changing in the magnetic flux will produce induced current. So to produce an induced current, we have three ways. The
Wire represents a closed circuit. Current can be induced in a closed circuit in three ways. One method is to move the circuit into or out of a magnetic field.
So again, we have three ways as we saw at the video. So we have three ways to produce an induced current. First of them, we can start moving the loop, or we can start rotate the loop, or we can change the intensity of the magnetic field. Lane's law, the magnetic field of the induced current is in a direction to produce a field that opposes the change of the causing it. So all the time, the magnetic field will be at the opposite direction. Because of that, we will see here at the formula, we have negative sign. So it's a question, why we have a negative sign? Because as Lane said, all the time, it must be at the opposite side. So again, now we have EMF. Actually, EMF is the power source. Now, when we have in this figure here a power source battery, we have it like V. But since there we have electromagnetic induction, that means we don't have a power source, electricity or magnetic or battery. So we have here EMF. It's electromotive force. The electromotive force equal to negative, because at the opposite direction, N is the number of the turns changing in the magnetic flux divided by the time. And we said before, phi is equal to B times area times cosine theta. So for example, we have a problem here. A coil with 25 turns of wire is wrapped around a tube with an area of 1.8 meters squared. So again, we have 25 turns, that's mean N equal to 25. We have area equal to 1.8, that's mean A equal 1.8. Each turn has the same area as a tube. Now we have a magnetic field is applied at a right angle of the plane. So when we have the right angle, that means we have a theta equal to 0. Now, if the field increases uniformly from 0 Tesla to 0.5 Tesla. So again, the electromotive force changing in flux. That means we have something changing inside the magnetic field. So here we have BI, the initial magnetic field, and we have the final magnetic field, which is BF. So BI is equal to 0 and BF is equal to 0.55 Tesla in 0.85 seconds. Find the magnitude of the induced EMF in the coil if the resistance in the coil equal to 2.5 ohm, and find the magnitude of the induced current. So as a given, first given we have here 25 N, and we have the area A equal to 1.5, and we have BI, the initial magnetic field, 0, and we have the final magnetic field PF, 0.55, time equal to 0.85 second, and the R resistance equal to 2.5 ohm. So to find the induced current, we need first to find the electromotive force EMF. Now the given, as we said, delta T, we have it, we have N, we have the area, we have the theta equal to 0, we have the BI, and we have BF. He's asking to find electromotive force, then we need to find the current. So electromotive force is equal to negative N times area times cosine theta times B final minus P initial divided by time. So again, it's N delta phi. Delta phi is equal to 1.8 cosine theta, which is the 1, times changing in the magnetic flux. So it's B final minus P initial divided by time. So it's equal to minus 29 volts. Now we can find the I equal to electromotive force divided by R from the Ohm law here. So again, I equal to EMF, or V is the same, divided by R. So I equal to negative 25 here, divided by 2.5, it's equal to negative 12 ampere. Don't forget, we have to put here the negative sign, because as Lenz said all the time, it's gonna be at the opposite direction.